Okay, good afternoon, everybody. My name is Mark Bunch. I noticed that we've still got people joining us on my screen. So if you don't mind, we'll just give it another minute or so just to make sure we can get as many people in as possible. And then I shall begin properly. Thank you very much. I shall talk to you soon. Okay, well, I think we've got about as many people as we're going to get. So welcome to a rather gloomy day up in the north of England. I don't know where you are, but it certainly looks like rain here. And welcome also to what is my first webinar for a number of months now, so I hope I'm not too rusty. What we thought we'd do, it's not so much the YouTube top 10 list of my favorite aspects of HAZOPs, but what I wanted to do was to just sort of introduce the subject of HAZOP and illustrate it with some of the things that I've noticed over my many years of doing this. I started out as a chemical engineer up until the late 1990s when I went into process safety, and more or less straight away went into the world of HAZOP and Hazard, and it's been my bread and butter for many years since then. So I hope that I've got some insights that might be of use to you. So with that, we'll make a start. I am, however, contractually obliged to just give you a little introduction to Sigma-HSE, who are hosting this webinar for you. Sigma are well, three prongs really to what we offer: consultancy, testing facilities, and training as well. We're based in Winchester in the south of England. We have offices all over the world, though, notably in New Delhi and Mumbai, both in India, Hyderabad in India also, Winchester and the States now as well, which means I have to update this slide to include the US office. Yes, I shall do that later. We have laboratories as well. Now, I was privileged to go down the other week to have a look at our laboratories in Winchester, and they are superb. I was very, very impressed. We mirror them over in India. We also run something called the Environmental Laboratory in, I think it's Hastings in the UK as well. But it's mostly for explosives, flammability properties testing, but we also do chemical reaction testing as well. Far more complicated than I am at present able to describe, but very impressive when you see it, I promise. Our consultancy services, this is where my main focus is: process safety management and its implementation, the industrial fire and explosion hazards, electrostatics, PHAs, that covers you. It means different things to different people. I always find the PHA, it stands for process hazard analysis, and it can be any one of any number of different studies applied to any stage in the design. That's something that I'm going to come back to during the course of this next hour. Functional safety, so electrical systems, electronic programmable, and safety instrumented systems. Chemical reaction hazards I mentioned, and training workshops as well. The testing, we do fire and explosion properties, gas and vapor properties, high electrostatics, all sorts of chemical reaction testing and regulatory testing as well. Now, we do have webinars on the testing facilities and Desir and things like that, which you would be very welcome to join us on. I think we're going to run some of those quite soon as well. But for me and for you for today, we're going to talk about HAZOP. And I've split this up somewhat into various stages. So it's going to be a little bit of introduction to HAZOP, first of all, what it is, how it works, and the kind of things that we need. And then 3 real tranches, if you like. It all centered around the workshop, the actual hazards study itself. But there are things to do before, there are things to do during the workshop, and there are things to do after the workshop, which all make a difference to how successful your HAZOP is. Now, I've got another one in there, which is after the workshops and longer after the workshops. And this is it's a facet of the HAZOP study that there are things to do, even some months after the study has actually been completed. And it's an aspect that is frequently missed. So I wanted to say a little bit about that as well, or at least give you some examples from my experience of having run these things for a while. But that's our agenda for today. So we shall start off with this introduction to what is a HAZOP and how it works. So we're giving you some, words here, but it's, there are key words in it: structured and systematic. So it follows a methodology, the HAZOP study, an examination of a planned or an existing process or operation. And what we're trying to do is to identify and to characterize any problems that present a risk. And that can be to people, it can be to the environment, or it can be to the operability of your plant, which means whether you're going to make money at the end of the day, how easy it is, how resource intensive, and how likely you are to have an incident, because it isn't any of those things. It's part of a suite of hazard studies, which were developed by ICI back in the 60s. Instrumental in that was a fellow called Trevor Kletz, whose books you may come across on process safety. He was what was called an industrial chemist, but the chemical engineers sort of adopted him and brought him into the fold, as it were. But he was head of what was really the first process safety group for a major company, and thought about it very cleverly and very long, and came up with this idea that different levels, or different abstract levels, when considering a design, are appropriate depending on how advanced that design is. So if all you've got is an idea that you want to make some chlorine, but you've got no process to do it, nowhere to site it, you can at least make some upfront decisions. Some of these might be things like, well, we're not going to put it in the middle of Birmingham because we know that chlorine is toxic. Those kind of things you can do as part of a conceptual study, and it informs the design ongoing. After you've got a process, you might just have a block diagram with a bit of goods in, some storage, some processing, separation, finished products, etc. You're able to interrogate that a little bit more. You might have some ideas of temperatures and pressures, for example. So something like a higher level study, or a HAZID, would be appropriate for that level of detail. And of course, once you go into detailed design and you've got P&IDs that you're comfortable with, the HAZOP is the place to go. Thereafter, there are other studies that can be done, and that's the long after the workshops bit that I shall come to in a little while. I've changed this slide somewhat. I've said it used to be just say a qualitative technique based on guide words, and it's less so now. What I've noticed is over the years, we've introduced scoring for risk being the combination of consequence or hazard and the frequency or the likelihood that something occurs. So you can have a high hazard but a low risk because you make it less frequent that you get a loss of containment or have an incident. Equally, you can have a relatively low hazard site, but if you're constantly letting stuff go, that might be high frequency, and that contributes to the risk. So to do a score based on risk is a good thing to do. It aids in design and it aids in decision making going forward. It's the way in which you prioritize how the HAZOP informs the design. So semi-quantitative is much more common these days. It never used to be like that. Carried out based on guide words and is carried out by a multidisciplinary team, which I shall say more about in a few minutes, over a series of meetings or workshops. So it's structured and systematic, qualitative or semi-quantitative. It's rigorous. Every time I go into a HAZOP, I always ask people if they've had them, if they've done them, participated before, and about 50% of them have. And I always ask them, how did you find the experience? And it would be uncharitable to say that everybody hated them. But they are tiring because they're so rigorous, because you are in a room for a number of hours, looking very, very carefully in a detailed and intelligent way at some drawings and documentation. So it can be, tiring and stressful to do so. However, a lot of people enjoy them, and I'm one of those people. And if nothing else, let's hope my enthusiasm for the process comes across somewhat. One of the things that I would like to mention as a feature of a successful HAZOP is the timing. It's when to conduct it. And we've given some examples here. So during feed, front-end engineering design, during detailed design, and the result of any design change, during pre-commissioning, normal operation, and for an audit requirement are all times when you can do them. My advice would be, don't do them too early and don't do them too late, which sounds unhelpful. But the idea is that if you do them too early, a lot of the information that you need for a successful study might not be available to you at that time. And that means that you're going to get a lot of actions out of the workshop. And actions take up time and resource, and therefore they are an expense, they're a cost. So in order to limit that, we try not to do them too early. And by contrast, if you do them too late, you end up with a different set of problems, which also might cost you. Because if you do them too late and you find that there are changes to be made as the result of the analysis, then you may find that you've already bought the equipment that's going in. It's sitting out in a laydown area outside the offices as you speak. So any changes consequently become much more expensive as well. So that is also a cost. So getting it right, when you've got a set of frozen P&IDs that are as good as you are comfortable as saying so, that's a good time to think about doing the HAZOP when there's that trade-off, that balance between having that information available to you and already having spent the money. So there's another slide here, and this ties it in to what we call the life cycle model. Now, I'm hopeful that I can get my mouse pointer to show. Yes. Right, you should be able to see a red dot on the screen now. I'm very old and this is new to me, so bear with me. But it's the life cycle of a plant. We start off with the identification of hazards, first of all. Okay, so at an early stage in the design, again, if you're just thinking of making chlorine, you have no idea how to do it, we can do this conceptual study. It's at this stage that you can say, don't put it in the middle of Birmingham or in the middle of a major city. Let's put it somewhere sensible where if we do have a loss of containment, we're not going to hurt as many people. And that informs the design. The design becomes more mature, and consequently, we can do another study like the Hazard, and that informs the design. And we go around until we have something that we are happy with, that has been through the HAZOP process and is ready for construction. We can do other studies at this point, and I shall come on to that a bit later. But after you've constructed, you will be able to operate your plant. You will be able to do some inspection and maintenance whilst it's operating. And then, because you're good employers, every 5 years or so, or when there's been a major change, you will verify that everything you did up here in that hazard analysis still rings true. And that is because change happens. And this is not only change that you impose upon yourselves, you know, through natural improvements and so on. It's change that might be imposed on you from outside. People may leave. People with knowledge may leave. There may be changes in legislation, which is an outside change. There may be some more housing that goes up next to your plant, and that changes your risk profile. So all these things have to factor in to all the good work that you did 5 years previously. So it's an important thing to bear in mind and to be prepared to go through the experience again. You have my number. Since this is the introduction bit, we'll give you some terminology as well. Hazards within the context of HAZOP, potential source of harm, as the result of a deviation from the design or the operation of the plant that may produce a hazard. That could be a loss of containment, a flammable or a toxic material. That's what we're looking for. It's our focus in the study. And although you may have one hazard, it may lead to different or multiple forms of harm. So the loss of a flammable material could give, it could give you a jet fire. If it's liquid, it could give you a pool fire. If it's vapor or gas, it could give you a flash fire or a vapor cloud explosion. And these have different consequences. So a process hazard is one of those deviations which arise from a change in processing parameters. A processing parameter might be flow, might be pressure, might be temperature, and then the example here, it's level, which might give rise to an overflow leading to a loss of containment. It's as the result of the fact that you've got a process operating that this hazard has arisen. So it is termed a process hazard. Non-process hazards, by contrast, not associated with the process parameters, for example, falls from height or vehicle impacts, would be non-process hazards, but still candidates for evaluation within the study. Parameters, the characteristics of the process, the bits that we're interested in, typically the bits you see on the computer screen when you're looking at your process, temperatures and flows, etc. And a term that I'm going to refer to frequently is the design intent. We assume that as long as we are operating within the safe operating envelope, those are the conditions of temperature, pressure, etc., for which your equipment has been designed, then a loss of containment is not going to happen. A deviation is going to take us away from that safe operating envelope and can potentially give us a loss of containment or a deviation leading to a loss of containment. A deviation itself is just any variation in that process parameter from the design intent. Too much flow or not enough flow, too high a temperature or not high enough a temperature. Which brings us to the risks that's associated with it. So the risk associated with the process hazard and its consequence is the combination of frequency and hazard, as I mentioned earlier. And the process hazard analysis is looking at that. It's the systematic definition and identification of those hazards. Be careful, however, with process and occupational risk. The two ostensibly are looking to do the same thing, minimize the harm to people and to the environment and so on. But process and occupational risk are treated differently, mainly because the problems associated with occupational risk over the years, certainly in the UK, have more or less been solved. It's very rare these days that you will go out on site and see somebody without the correct PPE on. Process risks deals with the fires, the explosions, and the toxic releases, the things that can get you in the papers and can do huge damage to your share price, as well as to people, put you on the news. Occupational risk is handled through other risk assessments, things like COSH, things like human reliability and other ad hoc risk assessments. HAZOP is specifically looking at process risks, although if an occupational risk does crop up during the meeting, I'm never going to put people off writing it down. So this is where we get more or less into the meat of things. So what do we need to do before the workshops even begin? I'm at your mercy, essentially, as a HAZOP chair. It's the information and knowledge that we have in the room that is going to define how well we do it. So my job is to maintain independence. I'm not involved with the design. I'm there to ask really stupid questions, and I'm quite good at that. My job specifically is to guide you through the HAZOP process to make sure that we don't miss things. That's one part of it. But to manage the process effectively, to manage the secretary, obtain consensus from everybody who's there, and ensure that everybody gets a fair crack, everybody has an opportunity to speak, nobody feels belittled, and everybody feels involved. That's really the skill, or where the skill lies in what I do. But whether we are successful or not depends on you as the team. We need participation and with it some enthusiasm as well. And we need what resides in your heads, the knowledge and the expertise that goes with it, and the quality and quantity really of information that's available on the table in front of us. It's those three components, the quality and the availability of those three components, together with my expertise, that ultimately determine whether we have a successful study or not. So let's look a little bit about the documentation that we normally ask for, and there's a fair amount of it. It doesn't always arrive, so I'll get rid of the red dot now. Here we go. So for some documentation, we really need the piping and the instrumentation diagrams. They are what the HAZOP is based on. They are what we interrogate. Useful to have alongside them is the process flow diagram, which is typically a higher level block diagram of the process. And the reason I ask for these, and the reason I find them very useful, is it helps to orientate me and everybody else where we are in the process. It also helps me to lay out a logical progression for taking us through what it is that we're studying as well, simply because you can get more on the page. A layout is very useful. A layout helps us to not only see where everything is, but see potential consequences a little bit clearer. If we're going to get a jet fire and it's within a certain area, for example, impinging upon the canteen, that gives us valuable information about the likely number of people that we might hurt. Going alongside that, some occupancy data as well, where people are for the majority of their time, and therefore, do we have any targets who we can hurt with some of the loss of containment. A process description, this is going to give us the safe operating envelope. It's going to tell us how the plant is supposed to operate. It gives me valuable information about how things are supposed to work as well. And alongside that, supporting it, things like the cause and effect drawings. So these are, not every company uses these, but it's very useful to have simply because they're so easy to use, providing they're not, too busy. But essentially, it's the control, it's the actions that your instrumentation does that provides a safety function. So rather than ask people, okay, you've got a high level trip on the top of this tank, what does it do? We can look very, very quickly and see that the design is for it to close an inlet valve, stop a pump, or whatever it happens to be. Too many times I've asked companies what a particular trip does and they don't know. Other things, I put cause and effects in twice, never mind. MSDSs. So the safety data sheets for the materials that you're handling. Very useful for, in particular, for toxicity data. They're not strictly necessary for every HAZOP, and the reason is that I will always take the worst case. So generally, we will know if something is toxic or is flammable beforehand, without having the details spelled out for us. But occasionally, we do need to refer to them. A description of the control as well. the control system that sits behind. Sometimes we have to go to the equipment manufacturers for this particular compressor, or something might come with a panel associated with it and its control logic. So we need to know how that is intended to work. These last two I find incredibly useful. Past incidents, first of all. When was the last time you did this, I ask? And very often it was within living memory. So it's now a feature of coma sites as well in the UK, that a past incident review should be completed as well. But very often it gives us extremely good clues as to what might go wrong, the reasons for it going wrong, and what the consequences were as well. So I do like to have a look at any past incident data that is available, and previous hazard analyses as well. If things have been done, let's use them. Let's get some insight into what the thinking was, what the problems were, not only so that we don't miss anything, but also that we can add to that body of knowledge in a sensible way as well. So those are very useful documents to have alongside us at the same time. So I've got my documentation. I now need some people to help read it for me. And these are typically the role functions that I would ask for. So from engineering, I'd like somebody from the process department, the mechanical department, control and electrical, and maintenance people as well, because they know what went wrong the last time, because they had to fix it. Management, project managers. Project managers are generally very good at having a grip on timetables. So they help me in maintaining a sense of urgency about finishing before Christmas. Specialists we bring in occasionally, chemists, the equipment manufacturers themselves, who may have more details than we have in the room ourselves, so we call them in as and when we need them. And the most important person in the room, who I've put at the bottom but should really be at the top, and that's the operator. If I can possibly get an operator, they are absolutely invaluable. The number of times I've sat in front of a P&ID and the chemical and process engineer has described exactly how it works, and they'll say, yes, we open this valve, we start this pump, and then we fill the tank and everything's good. And the operator says, no, we don't. We don't use that valve anymore, we blow it in with nitrogen or something else. But everybody learns a little something that way, because not all knowledge about the way the plant works resides in engineering. It's very much the operator. The other reason for getting the operator involved in a process like HAZOP is so that they understand why it is that we ask them to do things in a certain way. It's not necessarily obvious from the operating procedure why that particular valve has to be opened before another when it's further away and he has to go and walk or climb a ladder to get to it, for example. This is an excellent way of describing exactly why it is that we ask them to do these things. So I would always insist where I can get an operator involved as well. So we've got the documentation. We've gone through it with our team members. Are we sitting comfortably is next. So it's good manners for a start, isn't it? That we should have somewhere comfortable and quiet and able to do this important work. Some amenities would be useful as well. We're taking people out of their day jobs, so let's treat them as if they're doing something important as well and give them a lunch to go with it. We have had some excellent HAZOP locations in the past and some excruciatingly poor ones as well, porta cabins at the end of a field sort of thing. But you're going to get better results from your people if you look after them that way. And the other thing I like to do is a site tour, if it's available to me, to actually go out on the plant, have a look at it, to have a look at the equipment, to see how it operates rather than just have it described to me as well. So that's a very useful thing to do where time allows. I do know what a pump looks like, so you know, if it's a simple job, I don't necessarily need to see it every single time, but for some processes it gives you a good context for everything that you're going to be discussing later on. Okay, so that's all set up before the workshops. During the workshops is next. And if you're going to be involved, it's the soft skills as well as the technical skills that very much dictate how successful you're going to be. So the chair should begin by explaining what the objectives are, what the scope is, and because not everybody does these things day to day, how the methodology works, what we expect from people. We do need to hear from everybody. Every voice matters. Everybody has an insight of their own, and sometimes those insights, however trivial in their own mind, can lead to big insights for the team. So I do like to hear from everybody. That's that last one, that respectful environment. No idea is too obvious or too small to go unmentioned. So good chair will also watch for things like dominant personalities who tend to manipulate the conversation. Some people are naturally gregarious, and each one of you listening to me now will recognize those traits in some of your colleagues, I'm sure. But a good chair will try to draw out contributions from people. As I get older, it's harder and harder. If I'm in a room with 17 people sitting around a table conducting a HAZOP, it's the names that get me. But I do try to remember people's names so that I can address them properly during the meeting. I could say, Andrew, what do you think? What would be the control answer to this sort of thing? It becomes more of a conversation that way. It becomes easier, and as people relax into it, that conversation becomes more and more valuable to me and for us to write down to get that consensus. Not only people, but the disciplines themselves. The disciplines are where that knowledge base is, so we need to hear from them all as well. Operations and maintenance are in there. Operations and maintenance are particularly important in there as well. So many accidents that we've had in the past have been as the result of an operational error or something left undone in maintenance, or something that was picked up in maintenance as well. So to hear from these people, I always enjoy. Okay, so the good chair will take you through the methodology. As far as possible, we will stick to that methodology because there's a reason it works. It's been tried and tested. It is the daddy as far as these hazard studies are concerned. So we will go through all the guide words, and I usually go through it reporting on everything I do, full reporting. Even if there's nothing to say, I will say that there's nothing to say about a particular deviation. Otherwise, you lay yourself open to the criticism that you've missed something. I try to keep the groups from drifting off topic, but if you're getting something valuable out of a slight deviation, then I'm prepared to let it go for a little while because something good might come out of it, always with an eye on the watch though. So if agreement or consensus is not being reached within a reasonable time, I will start what is known as the 20-second rule and announce to people that they've got another 20 seconds to reach that consensus. Otherwise, we will park it. We'll write it down what the issue is, put it in a parking lot and take it outside the meeting. That usually works. Not all the time, but for the most part that works, and people appreciate it as well, because everybody else knows when a conversation might not be going anywhere. So I also summarize any decisions that we've made or any consensus that we've reached before, well, sometimes before recording it, but just to make sure that what the words on the page match everybody's understanding. So no understanding gets lost that way. Other ways to make things flow a little better. I've said here, HAZOPs are mentally draining. That's a little dramatic, but they can be very, very tiring. So I do like to make sure that we get regular breaks. I don't usually go beyond an hour and a half without at least allowing people to stretch their legs, maybe grab a cup of tea, go outside, whatever it happens to be. And that's one of these soft skills of gauging your team for wandering eyes, people looking out the windows, those kind of things. And it is always better to pause and return after a little break. If you are running short on time there, work out beforehand what the critical nodes are that you want to study and do those quickly. So do those first. The minor ones can be picked up later, maybe in a 2-hour session on Teams or something afterwards, rather than try and rush the more important ones as well. So I've always got one eye on the secretary, who is writing everything down for us. It's always projected on a screen or on one of those enormous televisions that so many companies have these days, so that everybody can read and agree on what is being said. We need to capture the hazards, the causes, the consequences, all those safeguards, and the actions in clear, unambiguous language. And this last bit is actually a very useful little technique that I use a lot, and that is to repeat back and paraphrase, simply for my own understanding. You understand that if I've understood it in a particular way, everybody else has understood it in that particular way, and that's a very good thing to do, I find as well. Just bring your attention back. Where's my red dot? Here it is. So these causes and consequences. The consequences must be the worst case unmitigated. If you've got a loss of containment and it's lukewarm water, then nobody's terribly bothered. But if there's a loss of containment of a flammable material, don't report it as a slip hazard. It's got to be with the potential to ignite and create either a flash fire, vapor cloud explosion, or whatever it happens to be. Only then can you decide whether the existing safeguards that you've got in place give you sufficient protection. One of the things that I do, and I find this very valuable for clients, is I categorize the safeguards by type and by function. So you can categorize them in terms of the job that they do. They will either prevent, control, or mitigate an incident. If they prevent it, they prevent it from happening. If they control it, they fail to prevent it from happening, but you can control the rate of release once you've got a loss containment going on. So things like bunds and relief valves. And then the mitigation as well stops the harm progressing. So things like fire detection, evacuation plans, and the others. And it breaks the chain of events at some stage before somebody gets hurt. So that's the idea there. And the other way of categorizing safeguards is by type. So things like procedural controls, control systems, physical protection devices, and aspects of the design that mean that this scenario is less likely to happen. So if you fill in those safeguards and you find that everything is in a box labeled procedure, it's not terribly robust. What we like to see is strength in depth, and by doing that categorization, you can show whether you've got strength in depth. It shows you where you're spending money to reduce risk, and it shows you where you're getting value for money from that expense. So that's a very good thing to do, and that gives clients valuable information that they can use going forward, and use for regulatory requirements to make sure that they've reduced their risks to as low as reasonably practicable. Time management, yes, so a good chair again will estimate how long it's going to take per node. I usually do it on the basis of size and complexity. I try as far as possible to stick to it, but we all know how these things have legs. Sooner or later, we're going to realize that this is going to take us more time than we thought. So we try to manage that, and we'll either postpone a less important node until later. And that's this prioritization aspect at the bottom. Less critical ones can be handled more rapidly later. Now, on one of the earlier slides, I mentioned that HAZOP used to be entirely qualitative, and now it's more or less semi-quantitative all the time. So I would like to say something about scoring of HAZOP scenarios, and we do this through a risk ranking exercise. I do it outside the meeting, and I'll explain why in a second. So risk is this combination of hazard or consequence and the frequency or the likelihood. So how likely it is to happen versus how bad it can be. And we need for that a risk matrix. And there is a standard one, which is gives you 2 calibration points from the HSSE in the UK. It's published in a document called R2P2, Reducing Risks, Protecting People, which you can get on free download. That allows an overall view of the risk, and it allows you then to decide what is important to prioritize when it comes to actions in a world of limited resources. So a risk matrix may look something like this, and this one, as I said, is calibrated. The calibration points are here, which is for a single fatality at a rate of 10 to the minus 6, or 1 in a million, and here a rate of 10 to the minus 3, or 1 in 1,000, for a single fatality. Now, the difficulty is with the scoring that the difference between this point and this point is only 3 orders of magnitude. And I've got all those people sitting in that meeting, all with potentially different ideas about what those values should be. So to argue yourselves from broadly acceptable to intolerable is an easy job. It's only 3 orders of magnitude. Somebody says, I think it's a fatality. Somebody says, no, it's a major injury. Somebody says 10 to the minus 3. Somebody says, no, it's not, it's 10 to the minus 5, and so on. And before you know it, you're in the wrong box. So it's a useful thing to do without doubt, but don't think of it in terms of absolute risk. Think of this as a tool to be used for relative risk, so that you end up knowing what are the major things that are going to hurt you the most fastest, and get those to the top of the pile, because those are the ones that you need to prioritize. So if you're sitting in a meeting and it's been going on for 3-4 weeks, you can drift. And what we do is we have a set of rules for the frequencies associated with certain failure types, and because we've had the occupants and the layouts and we know roughly how many people that are there, we can use these rules to give an idea of the likely injury associated with it as well. If I do that outside the meeting, I know that I can be consistent about how I apply those rules, and that is tremendously valuable. It's not in the absolute risk, it's in the relative risk that goes with it. I will give you the major accidents, the ones that are going to hurt you the most, and associated actions with those, so that you can prioritize them, and you can see which of the safeguards are the important ones that are cropping up against those, and therefore are safety critical, and they're the ones that you need to take care of, test, make sure they're working okay, and so on. I mentioned R2P2, and this is the diagram that appears in there that gives you those calibration points. So we have a broadly acceptable region, which is fatality rate less than 1 in a million. That has a unit associated with it called a micromort, which I love. I think that's brilliant. A micromort is a 1 in a million chance of dying, and greater than 1 in 1,000, we are in the intolerable region, and really we should stop work at that point and put in place some risk reduction measures. And the tricky bit's in the middle. That's that 3 orders of magnitude difference, where we try to demonstrate that any further reduction in risk comes at a cost that is grossly disproportional to the benefit that that measure brings. That's just where that sits. I am not advocating that you use this technique, which is semi-quantitative, as a means of demonstrating that your risks are ALARP. There are better tools for doing that. Things like layer of protection analysis and risk graphs, not risk graphs, LOPAs will do that job for you far better, and they analyze the figures in a much more rigorous way. But for the point of view of prioritizing actions, This is a good thing to do. It's a useful thing to do. It gives the client very good information, shows them where they're spending the money, and allows them to make better decisions about where to spend future money as well. Okay, so that's during the meetings. We now come to after the workshops. We've been sitting together, become good friends over these periods of workshops, know everybody's foibles, how they take their tea and so on. What has changed in terms of how risky a particular process is? And the answer is nothing at the moment. It's the minutes that are important and the report that goes with it, but nothing is going to change until the actions are completed. Those are the things that make the plant and the process safer. So a report that does that for you is important. It's the minutes. We should include as a sort of packaging around that the dates, the team members that were involved, the documentation that was used, the methodology that was used, any major findings, and any general actions that are not linked to specific scenarios. So things like ensure that there is a DESIR risk assessment completed for the site, ensure that all the materials are suitably tested in Sigma's labs, for example. Those are not necessarily linked to a particular scenario. Well, they might be linked to many scenarios, but they can be applied generally to the process. This is useful for sort of auditing purposes, rather than making the plan. It shows you that you've done it, and it helps you to fulfill your regulatory requirements at the same time. So include with the report the appendices, which are the minutes, the appendices containing the marked up nodes and the P&IDs, so that people know the version that you were looking at and how the node breakdown was made, so that those minutes are given some context to be read within. I usually give a separate appendix with just the actions and the recommendations and the scenarios to which they refer as well. And the reason for doing that, especially if it's in a spreadsheet format, we can identify trends or multiple actions around the same issue. If all my scenarios are to do with an operator leaving a valve open or something like that, or a maintenance failure, it's a human type error. And that can point you in the direction of doing some in-depth local study on that particular aspect, whether it's human reliability or instrumentation through things like human reliability assessments and LOPAs and stuff like that. It might be a management system that we're constantly running up against. But that identification of trending is very, very useful indeed. If you include the safeguard in there, you can see where a particular safeguard, for example, one particular trip, is protecting you against a great many scenarios. It therefore becomes much more important in your mind to look after it. And that might indicate doing some further study along the lines of LOPA as well. That's pretty much all I've got to say about the report. I'm going to say more about the minutes, but as far as the report's concerned, it is really packaging that goes around it. It's there for auditing. It allows you to put everything in one particular file and know exactly what was done and how it went on. The real bits come after the HAZOP, this post-HAZOP bit. So after the HAZOP, nothing changes. I've said this before. It's just a paper exercise at the moment until the actions are completed. So we give you the actions as quickly as possible, scored and ranked in terms of their importance through that exercise I described. Some of these actions can take very little time, quick P&ID changes, for example, pump type change out, valve type change out, those kind of things can be done relatively straightforwardly and relatively easily. Some will take longer. So, for example, if a further study were indicated, another a DESIR study or a cost assessment or something like that, and that were the action, that's going to take time to organise as well. The other thing that we frequently find gets left to the last bit is the writing of procedures, simply because you don't know what the thing looks like during the design. So those need to be done later on as well. But either way, you'll need to make sure that everything that was identified in the HAZOP and had an action assigned to it is completed. So I recommend, and clients never do this, some form of action review. Again, get the team involved, preferably the team that were involved in the HAZOP itself, because they understood the conversation that went along with it. And they can understand the response to the action in the context of the scenario that precipitated it. Because my secretaries are very good and they always write everything down, there's never any question that anybody wouldn't understand, because we always write in full English sentences rather than abbreviations as well. And there's a reason for doing that. It's because these things are documents that need to be looked at later on and throughout the life cycle of the plant. So do that, please. Write in full English sentences. It makes my job later on much, much easier. It might be that when we reviewed the action response, we get a follow-up action or some other action that we hadn't thought out during the original workshop, but now occurs to us as the result of the response. So that can then be recorded. That allows me to work out what the residual risk is after the action has been completed. We can then ask the question, what more can we do and why haven't we done it? Are we ALARP? And finally, we can mark that response as being complete. And at that point, we know that we've made the plant and the operation of that plant and that little bit safer as well. We've done an effective job in that sense. So we're coming up. Oh, my timing is, I'm a little early this time, but that's because I like the subject, you see. So we'll just give you a quick summary. I've talked about the preparation before. That was to do with the documentation that goes up front, sourcing a good location, sourcing a good team that's going to be able to support me, doing things like setting up the nodes beforehand makes a big difference as well. Getting the node descriptions in from the process description, having that good documentation up front reduces the amount of time you're faffing around during the workshops themselves. So preparation is a good thing to do. The documentation, its completeness, its legibility. There's no point going in with a 130-page process description if I can't find things in a reasonable time. So if you can go through the documentation beforehand, that makes a big difference. You might be able to pluck out the bits that are relevant to the node that you're going to be doing the following morning, for example. That's a very useful thing to be able to do. Getting the correct team, even if it's I prefer to keep the teams as small as possible, but without losing the knowledge that's required, and call people in if necessary, rather than have 17 to 20 people in there. Because it's more people for me to keep my eye on, if you see what I mean, make sure that they're okay with what's going on. It also means that I can keep side conversations to a minimum with a smaller team as well. This is all those soft skills that I described earlier. It's got to be a 50-50 balance between technical knowledge, methodology knowledge, and these soft skills. Actually, that's going to be 33 and a third for each of those, isn't it? Because there's 3 of them. But you get my point. It is very much incumbent on the chair to manage that process effectively. If people are getting tired, they get of less use to me because I'm going to miss stuff that could be important. So I have to make sure that they are available to me at all times. The technical knowledge of process risk and the HAZOP methodology that goes with it. So if people don't know, I will give them perhaps a half-hour PowerPoint presentation in the similar vein to what you've seen today on what HAZOP is and what we expect of people in the meeting. I talked about reporting. Now, really the report is nothing special. It is for auditing purposes, and the key things are in the minutes and this last point, the action follow-up, the completion of the actions, making sure that the plant is as safe as we can possibly leave it without it just being a paper exercise. Now, for my clients, this is where the added benefit of that risk ranking and of that categorization of safeguards gives you a little bit of extra value as well, because of it showing you where you're spending money and where you're getting value for money, and where you might be best placed to put any additional resources that you've got going without wasting them. So those are fringe benefits in addition, and that would be, I would say, one of the features of a good HAZOP as well. So thank you very much for your attention. We're just coming up to 4 o'clock now, so I haven't done too badly. Thank you very much for being with us. If we can be of any assistance to you, you have our address and our email. I know that Joe has been listening in and taking any questions that you might have had as we've been going on. He'll pass those on to me and I'll answer them as best I can the next day. So I'm actually in a HAZOP tomorrow, so it might be Friday. Because otherwise, I really appreciate all of you turning up for this. It's one of my favourite topics and I enjoy it, so I'm grateful. Enjoy the rest of your evening and we'll hopefully see you again soon. Bye for now.